Hello, my dear students. In this session, we will speak about the alloys. We have taken the last session how to extract iron from its ores and how to get rid of all impurities or most of impurities from iron, then adding some of elements or some elements and some substances inside the iron to give it a very good criteria, or to improve its physical and mechanical property, or to improve its chemical property according to the industrial use. So in this session we'll speak about alloys. What is alloys? Alloys is a mixture of two metals or one metal and another non-metal. There are three kinds of alloys. We'll take in this session the three kinds of alloys and how we can prepare it. Okay? The first thing is some examples of these alloys. Here we have nickel. So this is an iron plated with nickel, or an iron steel screw and covered with a very small layer of nickel. So it is a ferro-nickel alloy. And there is also a ferro-vanadium alloy. If you remember that from the economic importance of the main transition elements, we say that we have said that the ferro-vanadium is used also in car hood engine and the car springs. Ferromanganese is used in railway track and electric saw disc, and ferrochrome alloy is used in the cooking pans. But here we have to notice that the general definition of the word alloys. Alloy means a mixture of two elements. One of them is metal. It is supposed to be that one metal and the other a metal also, or metal and non-metal, or it may be composed of a lot of metals. But here we have to notice that there is a main metal, a main structure of the metal. The main component of this alloy may consist about not less than 90%, and the other components, whether they are metals or non-metals, do not exceed all of them about 10%, and the main component of the metal is about 90%. So this is just the examples of metals and metal and metal. Okay, there is also an alloy formed from a metal and non-metal, which is carbon and and iron. Iron carbon may be something, a type of alloy which is called interstitial, and in some case intermetallic. So if it is just a mixture between iron and carbon, it is steel, or it is interstitial. If there is a chemical compound Fe3C, it is a compound and it is an intermetallic. There is a compound, a reaction forms a compound, not just a physical mixture. So iron carbon is two kinds. We have to differentiate between them. If it is just a mixture between a whole structure which is iron, and some traces of carbon inside the intermolecular spaces of iron atoms, in this case it is called an interstitial alloy. If the iron reacts with carbon and the whole structure or the main structure of iron, and some little carbon is found in them, and forms an alloy which is called cementite Fe3C, and there is a reaction and forming a very hard alloy. In this case it is called intermetallic, though carbon is not a metal, but it is from the intermetallic alloys. Okay, how can we prepare alloys? There are two methods in preparing alloy. The melting method. Here we make a ferromanganese. How we make a ferromanganese? Through one of the two ways. Manganese and iron are melted together, and we leave this melt to cool gradually. So iron, manganese heated till they are liquids, then leave both of them together to solidify, then it makes the alloy of ferromanganese. Any other metals or any other alloys of metals can be prepared in this way, and it is called the melting way. Melting way means we heat both metals, both the two metals or the three metals which compose the alloy, and then leave them together to cool gradually. When they are cooled gradually, they form the alloy by melting method. Another way we can, this is the first way, the melting method, and the other way is the electrodeposition method. And from its name, it is we use electric current from an external source, and we make a deposition of two metals on the same time, at the same time. At the same time means we make like this door handle, we cover it by a layer of brass. Brass means copper and zinc. So we can connect this handle with the cathode or the negative electrode of the battery, or the negative pole of the battery, to act as cathode. Then we will make two columns of copper and zinc to be connected to the positive pole of the battery, and a solution of mixture of zinc and copper salts. Then from the anode, which is zinc and copper, they dissolve, copper and zinc dissolve in the solution and deposited on the cathode. We'll take this electrodeposition in detail in the electrochemistry in the fourth unit. Okay, so there are two ways or two methods to prepare the alloys. Melting method, we melt the metals together and leave them to gradually cool. Or electrodeposition, where we can electrodeposit two metals at the same time in the electrolytic cell. So here there is a lot of examples which can be electrodeposited, or which can be made by the electrodeposition or made by melting method, like copper and zinc, when they are simultaneously in the same time electrodeposited on the handle of the door, like this. Handle made of steel or iron can be plated or covered by a layer of zinc and copper in the same time. So here we have these types of alloys. Types of alloys here: interstitial alloy, substitutional alloy or substitution alloy, and intermetallic alloy. So interstitial alloy, from its naming, it is something we place in the intermolecular spaces between the atoms. So if we put atoms with very small size than the original atom of the main element, it is called interstitial alloy. If this element which we substitute inside the crystal lattice of the main element has the same size or similar in size with the main element, so we call it substitution alloy. If there is a reaction between two elements, in this case we call it intermetallic alloy. So if the alloy is mixture, physically mixed with each other, so it may be interstitial if the introduced atoms inside the main element is smaller than the main element atom in size. If they are both have the same size, in this case it is substitution. If there is a chemical reaction and forms alloy with a chemical formula which does not obey the valence rule of both elements, in this case it is called intermetallic alloy. So let's speak first in the interstitial alloys. Look here, iron is composed of crystal lattice, arrangement of atoms composed of atoms in compact rows. They are compressed or compact rows upon each other. When we hammer these layers, there is a slipping. Atoms go here and go there, so the ductility and malleability, means shaping of the metal, can be easily attained. So when we put some atoms inside these intermolecular spaces, okay, we know that iron, if you remember that it is 1.17 angstrom, it is its size. So if we put something like copper, is like carbon, which is 0.66 angstrom. It is nearly half the size of iron metal. So in this case, carbon will be in the intermolecular spaces between the atoms, so it prevent these atoms from slipping upon each other and prevent these layers from slipping one over another. So it makes the hardness of the formed alloy more harder than just iron. Okay, so in this case, if we put or place another atom or another metal inside this or non-metal inside this intermolecular space, and the size of the atom introduced into the crystal lattice of the main atom, of the main element, is less than the original element size, in this case it forms interstitial alloy, and in this case it causes the alloy to be harder than the original metal, and it affects the physical properties like magnetic property, electric conductivity, melting point. All these will be affected by introducing a metal with a small or an atom with a small size in the intermolecular spaces between the atoms in the crystal lattice of the metal. So here we have steel. Steel here is composed of metals and non-metals, of metal and non-metal. Metal and non-metal, metal is iron and non-metal is carbon. Carbon introduced here with a small size in the intermolecular spaces between iron atoms, so it prevents its slipping, the slipping of layers of iron metals upon each other. So in this case it causes a hardness more harder, or makes an alloy which is more harder than the original iron. So we called it a steel. It is composed of metal, which is iron, and non-metal, which is carbon. And it is important in the questions when you ask it that what is the alloy which is formed between a metal and non-metal. It is very famous, iron and carbon. When they are mixed together, physically mixed, they form what is called steel alloy. Steel alloy is formed by just mixing iron and carbon. Iron composes the main and the high ratio of the steel, and then some very little amount of carbon. Okay, we called it interstitial alloy. There are two cases afterward, the substitution alloy and the intermetallic alloy. Substitution alloy, as we see here, there is some metal atoms replaced by another atom. So if the two metals have similar size, similar crystal lattice as a whole in shape, and same chemical properties, then they form with each other what is called substitution alloy. Substitution means we substitute one of the atom in the crystal lattice with an atom of another element which has the similar atomic size, similar crystal lattice as a whole, and similar chemical property. Okay, so here when we replace one atom with another, have the same atomic radius or the same atomic size, same arrangement of atoms in the crystal lattice, and same chemical property. In this case, same chemical property of the original element. So two elements, one major elements with a major ratio, higher ratio in the alloy, and another metal with the similar size, similar radius, similar shape in atoms in the crystal lattice, and similar chemical activity or similar chemical property. In this case, we form what is called substitution alloy. When you ask it that there is a substitution alloy from iron and chromium, why it is called substitution alloy, and it is called stainless steel, not steel. Steel only is carbon and iron, but if it is stainless steel, it is chromium and iron. So why chromium and iron forms what is called the stainless steel alloy, and it is a kind of a substitution alloy because both of them, iron and chromium, have the same size, have the same radius, have the same volume. The atoms of iron and chromium have the same volume and have the similar shape in atoms in their crystal lattice and similar chemical activity. So because of these three reasons, they form a substitution alloy. Examples of substitution alloy: ferrochrome and ferronickel and copper gold. They are substitution alloys. Here we see that iron and chromium used in cooking pans because they withstand high temperature, and there is no corrosion because of the chromium for this alloy at high temperature. So here, when you ask that ferrochrome is a substitution alloy because of the similarity of the atoms between iron and chromium in the atomic radius, this is the first reason, in the shape of atoms in the crystal lattice, and in the chemical properties. So let's have or speak about the third kind of alloys. It is a chemical reaction, and the alloy here is a chemical compound. It is not just a physical mixture. It is a chemical compound, very hard, composed of two elements. So these elements must be from different groups in the periodic table and form a compound. In the compound, they do not obey the valence rules in ordinary condition or in normal conditions. Okay, when you ask that, the lead gold alloy is one of the intermetallic alloy because lead here is from other group. It is from group 2A, and gold from group 1B in the transition elements under copper and silver. So they are from different groups, and they form a compound AU2, AU2PB, gold and lead. Okay, they form a compound with a special formula, chemical formula, which does not obey the rule of valency. So in this case, it is a chemical reaction between two elements not related to the two elements is not in the same group in the periodic table, so they are intermetallic. Not in the same group in the periodic table, and there is a chemical compound formed. It is not a just mixing. It is not a just a physical mixture. It is a compound, chemical compound, and this compound does not obey the valence rules. Means here lead may be +2 or +4. Gold here, the normal oxidation state is +3. So when we make some exchange of the like the rules, how we name or how we write these chemical formula, it does not obey the rule. If it obeys the rules, then it may be that AU4 and lead 3 here. Okay, so it does not obey the rules of valency in normal conditions, and it is a chemical compound, and this chemical compound is not just a physical mixing, it is an intermetallic alloy. So if it has a chemical formula, it is not substitution and it is not interstitial. It is a chemical mixture or a reaction that happen and form this compound, and it is an intermetallic alloy. Another example, a cementite, it is Fe3C, and it is not interstitial. It is not a physical mixture like steel from iron and carbon. It is a chemical mixture, or it is a reaction forming Fe3C, a compound. So it is related to the intermetallic alloy, and this is a chemical compound, very hard chemical compound. It is not just mixing between iron and carbon like steel. We mix iron with a higher ratio with very small little size carbon atoms inside the intermolecular spaces without any reaction. So if there is a reaction and forming a compound which is Fe3C, which is cementite, it is intermetallic alloy. There is a very famous intermetallic alloy, aluminum nickel and aluminum copper. We call this alloys Dur aluminum alloy. Dur aluminum alloy is composed mainly of aluminum and some little amount of nickel or copper. So when you ask that, there is an alloy formed of more than 90% it may be 94.4% of aluminum and some little amount of manganese, magnesium, and about 5% or 4.5% of copper or nickel. It is one of the door aluminum alloy, and it is from the type of intermetallic alloys. Okay, so cementite alloy is an intermetallic as they form a compound with a chemical formula Fe3C, which is called cementite, and it does not obey the rule of valency or the valence law. Okay, so let's remember with each other. Let's remember with each other how to mention 5 examples of alloys which contain aluminum in their structure. Which contain aluminum in their structure. We have taken 5 of them, 5 types of them. Okay, remember with each other. First, in the first transition series, here, look at here. Okay, if we have a periodic table, or remember with each other, look at this. Oxidation states of aluminum. Yes, here, like here. Here we have the same arrangement of the elements of the periodic table of the first transition series elements: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, and copper. So we remember with each other the alloys formed with aluminum. Here, scandium with aluminum makes MiG fighter. Titanium with aluminum makes aircrafts, okay, and space shuttles. Manganese with aluminum makes the cans of the soft drinks. And nickel with aluminum, copper with aluminum makes door aluminum alloys. Okay, so there are 5 examples of aluminum here with the first transition series. Aluminum makes alloys with 5 of the first transition series: scandium, MiG fighters; titanium, space shuttles and aircrafts; with manganese in the cans, in the manufacture of cans, which is used in soft drinks; and aluminum, copper, and aluminum, nickel, which are called door aluminum alloy, and they are part door aluminum alloy. Aluminum, copper, and aluminum nickel is from the intermetallic alloys. So let's have some examples. Berzelius is an old scientist. I think he is in 16th century or 17th century. He speak about the metals and the non-metals. He make a classification of metals and non-metals, and organic and non-organic compounds, metals and non-metal elements. So he classified the elements according to their appearance, electric conductivity, and physical property into metals and non-metals. So all of these elements composed of X elements only. X means metals, except some alloy which is formed from metal and non-metal. Door aluminum alloy, it is copper, which is aluminum, metal and copper, or aluminum and nickel. They are all metals. Okay, brass, copper, and zinc. Lead gold alloy, which is a kind of intermetallic alloy. Okay, Au2, Pb, which is intermetallic alloy. They are both metals. Steel here is an interstitial alloy of non-metal, which is carbon, and metal, which is iron. Okay, this is the exception, which is formed from X, which is metal, and Y, which is non-metal. All of these are formed of metals. Let's have another example. Here, which of the following pairs of elements does not compose alloy? Zinc and copper, brass; iron and carbon. It may be interstitial alloy in steel, or it may be cementite Fe3C intermetallic. Gold and copper, substitution alloy. Here, iron and mercury, it is not an alloy, because mercury in normal condition a liquid, it is not a solid to make an alloy. We all know that alloys are solids, so this is not alloy, and this is the correct because he asked about the exception. Which of the following pairs of elements does not, the exception, compose an alloy? So this is the only one which does not compose an alloy: iron and mercury. Mercury cannot form alloy in normal condition. So if we make some mixture with mercury, it's called amalgam. So you do not have to remember this. Mercury with iron cannot form an alloy, and this is the answer. Let's have another example. Here, which of the following represents one of the iron alloys? This is a pure metal. This is not alloy. Okay, this is not correct. This is not a crystal lattice, an ordinary or normal arrangement of atoms inside the metals. Metals are arranged properly. It is not like the non-metals, so it is not a metal at all, or cannot form an alloy. Alloy is formed from one major metal, one major ratio, and some traces of another element inside the crystal lattice of the main elements. It is not in the same ratio. Both elements not in the same ratio. It is not an alloy. So this is not correct. The correct one is an alloy, major element with a very high percentage and some few little amount of another element inside it. If it is small and smaller in size, it is interstitial alloy. If it has, like here, the same size as the original element and the same shape of arrangement inside the crystal lattice and the same chemical property, it is called substitution alloy, like here. And this is the correct one. It is alloy. This is a pure metal. It is not alloy. The alloy has not the same ratio with both elements. It is not practically correct, and this is not a metal at all. It is not the arrangement of metals. Metals are arranged in a compact rows like this. So this is the correct answer. Which of the following represents one of the iron alloys? It is B. Here, the opposite figure show water bucket here made of galvanized iron. Galvanized means plating or covering metal with zinc. So when we have a molten zinc and dip in it any metal and come out from with this metal out from this melt, there is a cover or a layer of very thin layer of zinc upon this metal. So this layer of zinc or this process is called galvanization. Galvanization means covering any metal like iron with zinc. Okay, this is iron covered with zinc. And a door knocker. This is the door knocker. Okay, made of brass. If you remember brass, it is a copper and zinc. So what is the question? What is the common element in the two materials of the bucket and the knocker? We mentioned zinc 2 times. Here, iron plated with zinc, covered with zinc layer. Here, door covered with a brass which is made of copper and zinc. So zinc here is the common. Let's have another example. Okay, here the opposite table shows the component of an alloy. Which of the following represents this alloy? So we see that, or we have said that aluminum in the door aluminum alloy compose the main component of door aluminum, which is one of the types of the intermetallic alloy. Aluminum here 94.4%, copper afterward 4.5%, magnesium and manganese as we have mentioned. So it is not a substitution alloy. Okay, as copper and aluminum not from the same group in the periodic table. Okay, it is not bronze. Bronze is copper and tin alloy, copper and tin elements, It is not interstitial alloy, as these are a mixture and a chemical compound. So it is intermetallic alloy, and it is called dur aluminum because it is composed, the main component here is aluminum, so it is a dur aluminum alloy. So this is the correct one. Dur aluminum alloy composed mainly of aluminum and some little amount of copper and traces of magnesium and manganese. Okay. Now at this point we come to the end of this session. God willing, we in the next session we will explain the physical properties and chemical properties of iron. Thank you.